Okay, so now we are going to talk about operators and then expressions. Now, you remember that in our previous part of this same section, we were talking about how to manipulate um, variables, how to change them. There are cases where we can add a variable to a variable and then store the value in another variable. There are cases we can subtract. There are cases we can, do a whole lot of these variables just to get our refined output or to get our output. Okay, so in this particular part, we are going to learn about the various operators we have in C++, the understanding arithmetic operators and their applications. We are going to explore relational or logical operators as well. Then gain insight into expressions and how to evaluate them. All right. So without wasting much time, let's just move into the general overview of operators, right? Operators basically in programming are symbols or keywords used in performing, operations on variables, right? Uh-huh. And in a bit, I will explain something little for you, which is not in the slide. It's called operands. Operators are different from operands, right? Operands are the values found beside an operator. All right. So operators are always found between operands. So variables can be an operand. Any value can be an operand. All right. But any value apart from operators, and you find that value to be outside or outside an operator, right? Or you find operators in between them, those two-sided values are what we call operands. And I will explain with examples as we move on. Okay, so they include arithmetic operators, and we all know the arithmetic operators. We have the less than, addition, subtraction, multiplication, and then division, right? We also have the comparison operators. That is the relational operators. Those operators are used to compare two operands or two things or two variables. All right. So we have the double equal to. Please take note of it. The double equal to. That is a relational operator. Okay. We have the not equal to. We have the less than, we have the greater than. These are all comparisons. So you want to compare whether two things are equal or whether two things are not equal or whether one thing is less than the other or whether the other is what's greater than the other. We use the what we call the comparison or relational operators. We also have the logical operators, right? The and, the or, and then not. The and, the or, and then the not operator, right? Then we have the assignment operator, right? We wanted to talk more about these assignment operators now. So, like I said, these operators are what's used to manipulate and compare data or either control the program flow. And what controls the program flow mostly is the what? Logical operators. Those are the operators that mostly control the program flow, right? You want to compare whether check whether this and this will give you a particular output, and then you perform this particular action. Those ones control the program flow, all right, and perform various computations. All right, let's move on. Now we are moving on to the type of operators. We are going to take them one after the other and then explore them. Okay, so the first one is the arithmetic operators. All right, the arithmetic operators, which we have the addition, which is used to add two operands or two values. All right, we have the subtraction, we have the multiplication, division, and then the modulo. All right, so all these operators are used in C++ and the arithmetic operators. All right, and let's look at some ways we can use these operators. Look at this. We are saying our normal thing we do, right? We are going to include the IO stream library. We are going to use the namespace std. and then our int main function. And our int main function is what I said is the entry point of your program. So your program is going to start, the compiler is going to run the program from that side. All right. So look at it very well. What did we do in our int main program um, function? What did we do there? The first thing we did was what? Declare and initialize two variables. So we declared num1 as what? An integer, and then we placed in 10. We declared num2 as an integer, and we placed in what? 4. So num1 simply means number 1, right? Num2 simply means number 2. And then all these variables have some values inside of them, right? Num1 has 10, and then num2 has 4. And then we are telling the compiler to print some results for us to see. And we are going to use these operators to print the results. And like I said, operators are used to manipulate variables, and variables fall under operands, right? Okay, don't confuse yourself with the operands for now. If you don't understand the operand, just forget about it for now. All right. um what you need to know is the operators are used for manipulating these what we call these variables. All right. So we are saying that output sum, right? And that sum, what is the sum? What is the value of that sum? We are saying num1 plus num2. What do you think the answer would be? Would be 14, right? Because num1 is 10, num2 is 4, and then we are adding them, and we are saying you print sum and then print the result you get from what? Adding num1 and num2. Okay. The second line, we are saying print difference, right? Difference equals num1 minus num2. So you could realize that with all these examples or scenarios, we have the operator in between the variables. So the variables in this sense become the operands. That was what I was talking about. So the variables are at the side, each side of the what? Operator. So they become the operand. So let's just print or copy this code into our compiler, and then we will. So those using the mobile phones, you can do same. Okay, you can also copy the program into your compiler and then do same. Try it and see if it works for you. Okay, so this is the program, and then it's going to print the sum, the difference, the product, the quotient, and then the remainder for us, because we are using the various operators, arithmetic operators. So you could see here that sum equals 14, difference equals 6, product equals 40, quotient equals 2, remainder equals what? 2. You see? So what will happen if we change any of the values? So let's make this one 20 instead of um 10. So I've changed the num1 from 20 from 10 to 20. So let's see the results now. So you could see it has changed, right? So we have 20 times, or 20 plus 4 equals what? 24. 20 times 4 equals what? 20 minus 4 equals 16. 20 times 4 equals what? 80. And then 20 divided by 4 equals what? 5. Then the remainder 20 modulo. If you find the modulo, that means how many times will 4 go into 20, and what will be the remainder? The remainder is what we want. And 4 will go into 20 how many times? To go into it 5 times, right? Hey, are you there? So it will go into it 5 times, and then there will be a remainder of 0. So that is why we have that. So you see how our simple calculators work. So these simple, so in that case, in the calculator's case, the input is going to be entered by the what? The user, using the cin. Very simple. Then you use these operators to manipulate and get the answer. All right. So let's move on. Let's move on. Okay, so now we are at the relational operators, right? The relational operators. Now, these operators are used to compare and return a true or false what? Statement or value. So it will compare and return a true or false. All right. So we have equal to. So maybe you have a value. This one we have the same number one contains 10 and then the number two contains 4. Now we are checking that is number one equal to 2 or equal to number 2. Then we are checking. We are letting the code check for us. Is number one equal to 2? So if it is equal to 2, it will return true. If it is equal to if it's not equal to 2, it will return what? False. That is what it will do. Okay. And we are also printing on our screen with the next statement or the next line. Is num1 not equal to 2? So you could see here num1, and we are using the operator not equal to. So is num1 not equal to 2? So it will go and check what is the value in num1? 10. Is it not equal to the value in num4? Is it not equal to? It's not equal to, so what? It's going to return true because it's not equal to. There is no way 10 is going to be equal to 4. I don't know the math teacher you had, but for me, my math teacher never taught me that. And we are also saying that with the next line, see out is num1 greater than what? Num2, and we are going to check for that as well. So you can check for all these ones greater than or less than, but we are going to check for these few ones and then see what the compiler prints for us. Okay, so let's run it. So you could see, so it's either going to return 0 or 1. 0 means false, 1 means true. Like I said, in the Boolean type of data, it's either true or false, 1 or 0, on or off, right? So with this one, if it's 1, that means it's true. If it's 0, that means it's false. So we are saying it's num1 equal to what? Num2. That's what we printed here. We told the compiler to print for us. And then we compared it. Num1 equal to 2. Is it equal to 2? No, it's not equal to 2. So it's going to return 0. So that is why we had 0 here. And we have see out. Is num1 not equal to 2? Or is num1 not equal to num2? We are having what? It's not equal to. So that means it's true. What you are saying is true. So it's not equal to. So it's going to return what we have here, 1. So that means it's true. And then the last one is num1 greater than num2. Is 10 greater than num2? Yes, 10 is greater than 4, right? So we have 1 printed here. Okay. So what will happen if we change this one to 10? Then that means 10 is not going to be greater than what? Num2, right? Is it? It's not going to be. So it's going to be 0. All right. So that is it for the um, comparison or relational operators. Let's move on to the logical operators. Now, the logical operators are for, you know, they are the operators in programming that combines multiple conditions, right? So it's a condition and then return a Boolean result. So just like what the logical operator will return, the same way a relational operator also return a Boolean result, whether true or false, whether 1 or 0 or on or off, right? Okay, so we are saying the logical operator, they mainly include and, or not. So logical and. So returns true if both conditions are true. So there are cases where you want to use logical operator. You want to check if the situations are all true. If they are all true, then it returns the true. We have the logical or. It returns true if at least one of the conditions are true, right? So there are cases where you are using a robot, you want the robot to send some data, and if any of that data is on, it should trigger an alarm. You have a security system that is checking for your doors, right? If someone is intruding, there is a sensor that is sensing whether someone is intruding, and you want that sensor to send information to the processor to sound an alarm if at least one of the doors see someone entering, right? So you use the logical operator, the or operator for this. And we also have the logical not. So it returns true if the condition is false or vice versa. Okay, so that is that for that as well. All right, so we are going to talk about expressions. Then we will end today's session. Then I'll call for plenty questions. Okay, so if you have any question, please put it down, and then you will be able to ask your questions. So we have expressions, right? And expressions is what? A combination of variables and operators. Very simple. And then the value that's what or the result of these variables and then operators. Very simple. And take note of this. The order of what operations, we have what we call PEMDAS or BODMAS. I hope at least if you don't know the PEMDAS, you should know the BODMAS from class 3 or class 4. I don't know the class though, but you should know from one of the classes. Okay. In C++, the order of operation is similar to the what? Uh, uh, PEMDAS or the BODMAS in mathematics, where the parenthesis is evaluated first, followed by the exponents, followed by the multiplication, and then the division from the left to the right, please. Okay, from the left to the right. And then addition and subtraction is also followed next from the left to the right. Okay, so let's look at this um, scenario here. We have the include IO stream, a constant we always need to bring, the using namespace we always have to bring, and the int main function. That is what is going to contain our program. And what are we writing? We are saying that int a equals b, int a equals 5, b equals 3, c equals 2, and then another variable called results. So we've declared how many variables? One, two, three, four, five variables, right? One, two, three. Okay, four variables. A, B, C, and results. These are all variables, and we've declared them as what? Integer. And all the variables, we've given them initial values except results. Results we don't know, so we didn't give it any initial value. So you could see the result is just alone. But with A equals 5, we have B equals 3, C equals 2. But result equals nothing. So we've just declared it, not initialized. These are petty things I need you to understand at this point of our session. Okay, so that you don't get confused in the next and then our subsequent sessions. So we also have result equals a plus b. So now we are telling the compiler that this result that we declared and we didn't give it any value, we are saying that now the result should be a plus b times c. And what is a? A is 5. What is b? B is 3. What is c? C is what? 2. And according to our board mass, what did we say? We are going to look at what? The parenthesis first, exponent if there is any, multiplication if there is any, before we come to the addition or the subtraction. So what do you think this answer would be? I want someone to raise his or her hand and then tell me the answer that will be given or shown um, in the results, right? What would be the results, the answer for the result? If you know your board mass, you should be able to give. So you just unmute yourself, or you raise your hand, you unmute yourself, and then you give me the answer. Oh, so should I mention names? Okay, Jackie.
Okay, so since you're multiplying first, you get 6 plus 5, which is 11. Yeah.
You get 6 plus 5. Okay. So Jackie is saying the result is 11. Jackie is saying the result is 11. So me, I don't know. Let's give it to the compiler to compile it for us to see the results. All right. So Jackie, please be on hold for us. If you don't get it right, we will laugh at you. Okay. And please, we are not laughing at anyone here. We are all learning. Oh, I didn't copy the right thing. All right, so let's run it and see the results for ourselves. 11. Wow. So Jackie, you are right. Congratulations. All right. So let's move on to the next one. Let's move on to the next one and see that one too as well. Okay, so with this one too, we are saying um the parentheses, they are very important, right? In some cases, if you don't want the uh, how do you call it, the program to follow the board mass, right? You want to perform some specific um, manipulations first before you use the normal board mass. Please include those ones in what parentheses. So here in this case, we wanted, even though we know in use with the order of precedence, right? Using the order of precedence, addition should be what manipulated last, right? It's at the last order of precedence, right? We are what doing that one first because that one is in the parenthesis, right? If you take off the parenthesis, these two parentheses here, it's going to rather what multiply first. But this time we have it in what parenthesis, so we are going to perform any action in the parenthesis first before we what move to the follow the normal board mass. Okay, so here in this case, we wanted to add the values of x and y first before we multiply it with the z. Okay, so with this one too, I need someone to also give me the results so that we try our hands on. We are ending the session very soon, so don't worry. Anyone to give the answer? Hey, some of you, I'm not seeing you. Let me check all the participants. Okay, so we have, should I mention names? All right, since none of you is ready, I'm just going to move on. Okay. So questions and answers, right? So bring in all your questions. We've ended the session for today. If you have any question at all, please bring it on board. All right. So Priscilla, your question.
Um, so you see that the previous page, the code, when you can you please go to the code? I can't.
The code here.
Yes, please.
Okay.
You see the line where the result is equal to the x plus y, blah blah and stuff. So I
Yeah.
wanted to ask whether the expression there that you have written there is necessary
Oh,
because
yes.
it doesn't have
That's
a semicolon at the end, and you said the end everything.
all right. That's a good question. Um, Thank you for the question. Okay. So what you see here, result equals you have the open and close bracket x plus y multiplying it with a z. So this is what the compiler is going to see. This is the only thing the compiler is what going to see. Okay. The expression you see here is what we call a comment in programming. So you could see here we have two backslash over here, and then we wrote this expression equals or expression x plus y. All these things you see here is a comment. So a comment is just explaining what is on that line, right? Sometimes we comment our programs just to know what each and every part of our program actually means. You end up writing, let's say, 1,000 lines of codes. right? And sometimes debugging becomes very difficult. So you need to comment your program so that you will know the exact location, the exact place to go and look at when you have an error in your code. So this is a comment, right? So it's not part of the program. It's just a comment here for you to know that the expression I'm talking about is the what? X plus y times z. All right. So when I run this, so let's run it and see something. You would even see that the comment is faded, right? With most compilers, all the comments are faded. All right. So you could see here expression. Can you see the expression is faded out over here? So that is telling us that it's not part of the code. If I take these two backslash off, then the compiler is going to recognize it. All right. So it's just a comment telling the compiler that um, this part of the code or the program shouldn't be compiled by the interpreter. All right. I hope that answers your question, Priscilla.
Yes, sir.
All right.
All
Thank
right.
you
Thank
very
you
much.
very.
Any other question? Any other question? Jacinda, Jeffrey, don't you have any question to ask? Um, Kiana, do you have any question? Benedicta, Evelyn, don't you guys have any question to ask? All right. It seems you don't have any question. And thank you for today. All right. You were all, in fact, most of you were punctual. Like you came on time. Some of I can see some people too. Some people couldn't join today's session, and that is fine. We are going to provide the link as usual in the group so that even if you are here and you weren't able to get most of the things we discussed, you can go and watch the video again so that you understand it. All right. So, like I said, thank you all for um, today's session. I'm so happy to meet all of you and introduce you to the C++ programming.